Hi everyone, this is the lesson 3 of Pytorch. Today we're gonna talk about the gradient descent, how this is important for neural networks, and how Pytorch can help us with that. And something important in Pytorch is a tensor. Tensor is a main block of Pytorch framework. Uh, Tensor have a attribute no named here is grad. You can set this for true or false. Neural networks we can say is works like drop down into a mountain. So you are in the top of the mountain and you need to drop down the mountain and you need to find the better path to do that. Is gradient descent help us into find the better path, like this emulator here. You can send this emulator. I give some points here, and the gradient descent find the better path to fit this function here. So if I give a hard challenge or a nice soft challenge, the gradient descent find the better function to fit all these points here. You can play this emulator is in the notebook in the link of this video now. So important part of Pytorch is a tensor. Here you create a tensor of two lines and two rows that requires gradient. So the Pytorch tracks our operation in this tensor. If we print x here, you can see that it's a matrix one by one here, two lines and two rows, and it requires gradient. We add this matrix by two value and print the y value here. Here we print the last function used, and you can see this add function used in the tensor y. This I print the last grad function used, and you can see the add function are used in this tensor. We create a z-tensor that is y plus multiplied by y multiplied by 3. You get the mean of this tensor. This is the tensor, 27 element in the matrix of 2 by 2. And we can see the mean of this value is the same thing is 27. All elements are equal here, and we can see the last function applied in this tensor is the mean backward function. Now we create a torch tensor, the 2 by 2, print the a value, and here is the value. This random value is generated, and we do this operation and see this tensor is not tracking. You have requires tracked to false. After that, they print a value and we can see this tensor. You will not have the last operation tracking in this tensor. If you set requires grad to true, you can see the some backwards operations is set to this tensor, and all tensor generated by this tensor, like a b tensor generated by the sum of this multiplication, is trackable too. You can track this tensor here. You can see the send backward function this last applied, and we print b tensor here. You can see the last function applied, and we now have out tensor here that is 27 value. This out tensor was created before. Here is the mean of Z tensor, uh, and you can see the last operation applied as the mean backward. If we set or run the backward function here, she's do a back propagation. If you don't set the parameter here, is a back propagation with one value. It's not doing anything with this value. It's the same value. You can see the nothing changing the tensor here. So we have x, x value here is the tensor with one values, and the grad attribute say the gradient of x here. Uh, this thing we gonna see in the next lesson, where you're gonna see more about back propagation here. Back propagation is the main part of Pytorch, so you have some lessons with back propagation. I wish that you like of the this video. You subscribe the channel, give your like. Uh, the main goal of this channel is to create a short lessons of Pytorch or other technologies, short lesson that you can see in just some minutes and don't get much of your time. Uh, I wish that you like, give your comments, your suggestions to improve the channel, to enhance your knowledge, to enhance your skills. Thank you.